Let me tell you a horror story. A team I know building AI applications, they woke up to a 4,000 pound surprise bill from a single overnight run. And this was not a data breach, it was not a cloud outage, it was nothing to do with any of this. It was an autonomous agent that got stuck in a recursive loop. They did not set any budget limit, no circuit breaker pattern, nobody was literally observing or watching, and it just kept calling an API until the finance team found it in the invoice. You see, the model was fine, it was working good. The infrastructure was the problem here. And you know what is the funniest part? Every single thing they needed to avoid, that disaster already existed, sitting quietly in open source GitHub repos that they have never even heard of or never bothered to look at. And this is not a one-off case, my dear friends. This is a recurring pattern in many teams that I observe. So I thought that I will create this video where I walk you through 5 of the most important open source repos that I think are crucial for production AI teams. By the end of this video, you will know exactly which repositories to pull in if you want to go from a cool agent demo to a production grade system that doesn't hallucinate itself into a regulator meeting, if you like, right? Or blow up your budget. And by the way, all 5 of these repos are open source, so you can literally clone them after this video and start wiring them into your stack today. Before we dive in, let me set the frame. Most AI teams are still optimizing for the wrong thing. They are obsessing over the next update of the model, the next model release, while their orchestration has no state. Their retrieval contains garbage. They have zero observability. They rewrite scaffolding on every project, and they have no strategy for inference pros once usage scales. What I'm going to show you is the exact opposite approach. Think of this as 5 open source workflows AI engineers can plug in to solve those boring, sexy, but absolutely critical production problems. Orchestration and state, observability and evaluation, retrieval that doesn't hallucinate, application scaffolding and workflows, and finally inference that doesn't wreck your budget. Alright, let's start with the one that would have saved the 4,000 pounds incident, LangGraph. So folks, this is our repo 1, LangGraph. The official link to the repo is in the description. At the time I'm recording this, it's sitting at around 31,000 plus stars and over 5,000 forks, which is a strong signal that a lot of teams are betting their agent workflows on it, not just tinkering on weekends. Now, if you haven't seen it before, LangGraph is basically a graph-based orchestration for language agents. You define your agents and tools as nodes in the graph, and it gives you durable, persistent state across long-running workflows. So why should you care? Because every multi-agent horror story starts with state and retries. Agent A calls agent B calls agent C. Something fails, nobody knows who owns that state, and you end up with these horror stories of thousands of pound bills overnight. With LangGraph, if your workflow fails at step 7 of 12, it can resume from step 7, not start again at step 1 and replay all the calls. The branching logic is actually in Python code. It's not some fragile paragraph buried in a 3000 token system prompt. When something breaks at midnight, the support team or whoever is troubleshooting are reading the code in Python, not reverse engineering from the prompt spaghetti, if you like. And one small but huge thing, human in the loop. LangGraph has built-in support for pausing execution, letting an human agent inspect and modify state, then resume. In regulated industry, that's not just a nice to have, that's a difference between a cool demo and a compliance sign-off. It's MIT licensed, which makes it friendly for serious commercial use. If you're building a multi-agent system and you don't have a clear answer to what happens at step 5 when it fails, LangGraph is the piece you're missing. Okay, orchestration is one thing, but once your agents are live, a different question hits you. When the agent makes a bad decision, can you tell trace by trace why it happened? That's where the second repo comes in, Langfuse. Again, the link is in the description. Langfuse is sitting at close to 27,000 stars on GitHub and about 2,700 forks, and it has become one of the default observability layers for LLM applications. Langfuse brands itself as open source LLM engineering platform, and practically that means full tracing for every LLM call, every tool invocation, every retrieval step, prompt management, evals, datasets, and a playground to iterate quickly when you see a bad output. In financial services, we don't know why the system did that. You see, I work in financial services, and in my projects, saying we don't know why the system did that is not an excuse. It's a compliance failure. Langfuse gives you the audit trail. You are not grabbing random logs at 1 a.m. You are clicking into traces, seeing the full stack, and understanding exactly which prompt, which model, which context led to that out. The other angle I really like is monitoring over time. The Langfuse team leans hard into evals, metrics, and observability. They support different evaluation modes, datasets, and can plug into frameworks like LangChain and Llama Index. That's how you catch what I call hallucination drift. where week 1 is clean, but by week 10, the system has quietly moved because your data or prompts change. Community-wise, people are very vocal about it. There are a growing number of open source projects listing Langfuse as a dependency, and the docs literally showcase big projects like LangFlow and Open Web UI using it. That's actually a good sign. You are not alone if you adopt it. Licensing-wise, it's a mighty for core product with some enterprise folders separated out. You can self-host it in minutes in a Docker container or go with their managed cloud version. So if LangGraph is the nervous system of your agents, Langfuse is the monitoring and diagnostics. This is how you stop AI did something weird or being a black box. The third one is for everyone doing RAG, which, let's be honest, is basically all of us, right? The repo I'm talking about is RAGFlow. The link to the repo is in the description. RAGFlow has exploded to about 80,000 stars and just about 9,000 forks, which is huge for a retrieval engine. Their positioning is very simple. Your model isn't hallucinating because it's stupid, it's hallucinating because your retrieval gave it rubbish context. RAGFlow is a full RAG engine that fuses strong retrieval with agent capabilities to build a high quality context layer for LLMs. What makes it interesting is the depth of the document understanding. It doesn't just chunk everything into a 512 token block. It has a deep document understanding pipeline that deals with complex layouts, tables, hierarchies, which matters if you are ingesting financial reports, regulatory filings, or anything ugly from the real world. Two features I really like and I would like to highlight if you're building production systems. One is the grounded citations. Every answer is linked to specific chunks of the document, and they even visualize chunking so humans can inspect and fix it. That's really beneficial in environments where you need to show your homework. The other one is flexible automated RAG workflows. It supports multiple data sources, multiple recall strategies, fused re-ranking, and can scale from personal projects to large enterprise setups. This project is under Apache 2.0 license and the release cadence is very active. The latest tagged release is from May 2026 with frequent updates adding things like new model support and agent features. You will see a lot of people on social media calling out RAGFlow as the go-to when they hit the limits of naive RAG. If you are serious about retrieval quality, fix the pipeline before you start blaming the model. RAGFlow is built specifically for that. So if your current RAG setup is just embed, dump into a vector store and pray, this is probably the next place to look into. Now, fourth repo, Dify. The link is in the description. This thing is an absolute rocket ship. Roughly 141,000 stars and 22,000 forks in the GitHub repo. And that's rare for an AI infra project, to be honest. Dify is like your standardized scaffolding layer for LLM app. It is an open source platform that combines workflow orchestration, RAG agents, model management, and observability in a single consistent interface. Think about what you normally do for a new internal AI project. You set up model provider configurations, you build a basic RAG pipeline, you wire tools, you deal with authentication, sessions, admin, deployment. You repeat that over and over, and every project is slightly different in undocumented ways. Dify standardizes the boring parts. Out of the box, it gives you a visual workflow canvas to build multi-step AI workflows and agents. It supports for hundreds of models from multiple providers and self-hosted setups, including anything OpenAI compatible. It has got built-in RAG capabilities for ingestion and retrieval. It has got integration hooks into observability tools like Langfuse and others. The community clearly loves it. There's a very active Discord, GitHub discussion forum, and a long list of community Helm charts and Kubernetes YAMLs for deploying it in more serious environments. The licensing is under the Dify open source license, which is based on Apache 2.0 with some extra conditions. It's still self-hostable, and they also offer a hosted cloud version if you don't want to run it yourself. So if you're in a larger organization and you are tired of rewriting the same scaffolding for every assistant, knowledge base, or internal agent, Dify can give your teams a consistent platform to. And last but not the least, repo number 5, vLLM. Again, the link is in the description. It has got around 79,000 stars and 16,000 plus forks, making it one of the most actively adopted inference engines for large language models. vLLM is basically easy, fast, and cheap LLM serving for everyone. It started in the Sky Computing Lab at UC Berkeley and has grown into a very broad community project with contributions from a lot of different companies and institutions. You might ask, why does it matter? It matters because your cost profile looks very different once your AI usage is real. It's running in production. At low volume, paying per token to OpenAI or Anthropic is fine. At scale, especially for high volume agents, it can become the biggest line item on your bill. vLLM gives you high throughput serving with features like continuous batching, paged attention for efficient KV memory, and a bunch of optimized kernels. It supports for a huge range of models and hardware from NVIDIA to AMD GPUs to CPUs and even plugins for tensor processing units and other accelerators. Now here's the pattern that I'm seeing and I can think of in the wild, right? So teams don't need vLLM on the day one. However, the ones who learn it early, even in a small sandbox, have a much smoother path when they need to move high volume workloads off managed APIs. It's Apache 2.0 licensed, so it's friendly for serious commercial deployments, and the release cadence is very healthy. The latest release is literally tagged in May 2026. So if you are starting to face questions like why is our AI bill so high, vLLM is the repo you should be quietly prototyping with. Alright, now that I have covered all 5 GitHub repos, let me zoom out for a second, because these are not 5 GitHub links that I'm talking about. This is the stack. Here's roughly how they fit together in a production AI system. LangGraph is your orchestration brain. It defines how agents talk to each other, how state flows, where you can put humans in the loop. Langfuse wraps the whole thing in observability. Every LLM call, every tool call, every retrieval step is traceable, is queryable, and it's evaluable. You actually know what your system is doing. RAGFlow feeds your model's truthful context. Instead of guessing from half-broken chunks, your agents get grounded, cited information. Dify standardizes your app layer and workflows. It's the place your teams go to build actual applications without reinventing scaffolding every time. And vLLM sits underneath as your high-performance inference layer once API costs start to hurt. Now, two kinds of teams emerge from this. The team who find out something broke from their dashboards, and the team who find out something broke because the customer screenshots a weird answer on a Friday afternoon. This stack is one of the clearest lines between these two categories. If you are an AI engineer or architect and you want to build systems that actually survive contact with production, these 5 repos are worth a weekend of your time. You don't have to adopt all of them on day one. And honestly speaking, when it comes to tools, there are many other choices in the market. And I will cover more in coming videos. But I would suggest start where your biggest risk is today. If your agents are flaky, look at LangGraph. If you can't explain bad outputs, look at Langfuse. If your users complain about hallucinations, fix retrieval with RAGFlow. If every project feels like rebuilding the same boilerplate, try Dify. And if your finance team is side-eyeing your AI bill, start experimenting with vLLM. I've put all the links of 5 repos down in the description, so you can click straight through, check the stars, read the docs, and decide which ones to trial first. And if you want deeper breakdown, the architecture decisions, the failure modes, the trade-offs I'm seeing in real enterprise projects, that's exactly what I cover in Agent Build newsletter. The link for that is also below. Drop your email in and I will send you long form versions with diagrams and real war stories. Now friends, if you found this useful, please hit like and subscribe. Share it with your fellow engineers. I plan to put more content on this channel regularly. So if you are interested in production grade AI systems, not just playing with the latest demo, please hit the subscribe button. And please don't be the team that learns about observability after the £4,000 invoice. Bye.